Good morning friends. I will introduce new idea about homogeneous function. Here I will consider one example. U is function of two variables x and y, which is equal to x cube plus 3x square y plus 2xy square plus y cube. Now in this example, if we are observing each and every term, then it is clear that degree of this first term is 3. Now about second term, this x and y, power of y is 1. This is 2 plus 1. Total degree of second term is 3. If we are observing third term, x is 1, y is 2, total degree is 3 and y cube is 3. Degree of each and every term is 3. Then it is clear that if degree of each and every term is same, then we are saying that this u function is homogeneous in x and y of degree 3. Means every function involving each and every term with same powers, then we are saying that this is homogeneous of that power, that degree. And here this function is homogeneous of degree 3, then I can write this function as either we can take x cube common or we can take y cube common. First I will take x cube common, then what will happen? X cube in bracket, remaining term is 1, 3 y divided by x plus I am dividing to the second term 2 into y divided by x square plus y divided by x cube. This total function I will treat as x cube into pi of y divided by x. Similar way, if we are taking y common, y cube common, then we can write this function as y cube into something another function x divided by y. Means this u is homogeneous, then we can write, if this u is homogeneous, then we can write this u as in this way: x cube pi of y by x, y cube psi of x by y. And again, if this is homogeneous, then itself each and every term containing in that equation of same powers, and we can write this equation in this way. Also, to check given function is homogeneous or not, we can replace x by tx and y by ty. Then what will happen in given equation? U of tx ty, which is equal to, I will write here, tx cube plus 3 into t square x square into t into y plus 2 into tx t square y square plus ty cube. Again here, this t cube or I will write here this as t cube x cube plus 3 into, this is t square and this t cube x square y plus 2 into, here is t and here is t square, this total become t cube into xy square plus this t cube into y cube. I can write this as, now h is equal to t cube into x cube plus 3x square y plus 2xy square plus y cube. This is nothing but u of xy. Means our this function we can write in this way: t of x, u of tx ty is equal to t cube into u of xy. Means in general, if our function is homogeneous, then we can write either this way, or you can write this function in this way, and again, if this is homogeneous, then each and every term with same degree. I will generalize this idea and I will write this idea in general form. If u in x and y is homogeneous function of degree n, then you can write number 1. This u we can write in this way also. X raised to power n phi of y by x, y raised to power n psi of x by y, and also u of tx ty is equal to t raised to power n u of xy. Means every homogeneous function of degree something n, then we can write either this form or this form or this form. Okay. With this help of, we'll generalize new idea for our partial differentiation. Before that, I will cover some examples how to find its degree and to check given function is homogeneous or not. Here example 1. If u is equal to x square plus y square divided by root x plus root y. Now again, observing this equation also we can check given equation is homogeneous or not. Here, if we are observing numerator and denominator, in numerator first term is of degree 2, second term is of degree 2, therefore numerator is homogeneous of degree 2. Now denominator, the first term of degree 1 by 2, second term of degree 1 by 2, therefore denominator is also degree, this is also homogeneous of degree 1 by 2. Therefore total degree is 2 minus 1 by 2, which is equal to 3 by 2. And this function is homogeneous, this u is homogeneous function in x and y of degree n is equal to 3 by 2. Okay, means by observing also we can find out its degree. And again, I will go through our method. That means I will replace x by tx and y by ty. Then what will happen? We will check. U of tx, ty, this is equal to t square x square plus t square y square divided by root of tx plus root of ty. This is equal to t square, I am taking common, x square plus y square divided by, in denominator I can write this root t into root x plus root t into root y, therefore I will take root t common, root x plus root y. This is equal to, now simplification of this term. Here this is t square divided by t raised to 1 by 2, means I can write t raised to power 2 minus 1 by 2 into x square plus y square divided by root x plus root y. This is equal to t raised to power 3 by 2 into x square plus y square divided by root x plus root y. This term is nothing but our u, this given function u. Therefore, I will write this as t raised to power 3 by 2 into u, or u is function of x. Means we can write u of tx, ty is equal to this term, and this term is called degree. Means u is homogeneous function in x and y of degree n is equal to 3. For next example, I will write here u is equal to xy square divided by x square minus y square. Now numerator containing power terms, and moreover numerator is in multiplication. Here degree of numerator I will try to find out. Here x raised to power 1 and y square. Total degree of numerator is 3. And degree of denominator x square y square, means denominator containing same powers term. Therefore this denominator is homogeneous of degree 2. That means total degree of this function is 3 minus 2 is equal to 1. Now again we will check this degree by using our method. Means I am replacing x by tx and y by ty. Then we get u of tx ty is equal to tx into y square divided by tx square minus ty square. This is equal to, this is t and this is a t square, means total t cube xy square divided by t square into x square minus y square, which is equal to, this is t cube and t square, t into xy square divided by x square minus y square, and this is nothing but our u. Once again we can write this function as in this way. Here power is 1. Therefore this given u, this function u is homogeneous in x and y of degree n is equal to 1. I will take another example. U is equal to x square plus x square y square divided by x minus y. Now here in this example, if we are observing that numerator is in addition terms and first term of degree 2, second term x square y square, total term of degree 4, means first term is of degree 2 and second term is of degree 4. Therefore this numerator is not homogeneous, even though this denominator is homogeneous. Means we'll say that this our function u is not homogeneous. Okay, let us try. We will try to find out by using our actual way. I will replace x by tx and y by ty. Then this u becomes t square x square plus t square x square into t square y square whole divided by tx minus ty. This is equal to t square x square plus t raised to power 4 into x square y square whole divided by t into tx minus ty. This is equal to t square into x square plus t square x square y square whole divided by t into, and this is not t, x minus y, which is equal to t into x square plus t square x square y square divided by x minus y. Now observing this term, here additional term is that t square, because our u is this. If you are going through our u, this is our u. This is our u, and you are getting this term as x square plus t square into x square y square. Means this term, this bracketed quantity is not equal to u. Means I will write this is not equal to t into u of x minus. Means we will not write this u of tx ty, which is equal to something t raised to power something into u of x. Therefore this function u is not homogeneous function in x and y. This is not homogeneous, therefore we will not talk about it. degree. This is not homogeneous in x and y. Okay. Now I will turn to another example. Here in this example I will take u is equal to sine inverse of x plus y divided by x minus y. We have to first check this function is homogeneous or not. If homogeneous, then we have to find its degree. Again, this u is function of sine inverse of x plus y divided by x minus y. I will talk first about its angle. Now, angle must be homogeneous. Here, this is numerator is of degree 1, here is of degree 1. I am talking about here angle only. Angle, this angle whose numerator is of degree 1. Denominator is 1, degree 1, here is 1, therefore denominator is 1. Therefore, this total angle is homogeneous. If total angle is homogeneous, then we can talk something about this total function. If angle is homogeneous, then we can talk about this function is homogeneous or not. Moreover, if angle is there, then angle and whose degree of numerator and denominator is same. Moreover, I will say that degree of angle is 0. Then this total function becomes homogeneous. Means this angle of degree is 1 and denominator is 1. Therefore, total degree of angle is 0. 1 minus 1. Therefore, here this angle is homogeneous of degree 0. Then surely we can talk about this. This sine inverse is homogeneous of degree 0. But let us, we'll try to go towards our usual way. Our usual way is we have to replace t by tx. U of tx, ty, this is equal to sine inverse of tx plus ty divided by tx minus ty. This is equal to sine inverse of, from numerator we can take t common, from denominator also we can take t common, then we'll get here this term, and this is nothing but only u of xy, and I will write here this as t raised to power 0, means u of tx ty, then this function is homogeneous, this given function u, this u is homogeneous in x and y of degree 0. Again I will go through this, just this example. You can easily try to find out this degree. U is equal to tan of x square plus y square divided by x square minus y square. Again, if you are observing this angle, angle is surely homogeneous and whose degree is 0, because numerator is 2, denominator is 2, total degree of this angle becomes 2 minus 2 is 0. Surely this function becomes homogeneous in x and y of degree 0. You can check this. But if I will consider this example, next example, u is equal to, suppose, sine of x square plus y square divided by x minus y. Now what will happen? If we are observing these two examples, this example angle is homogeneous and moreover degree of this angle is 0. For this example also this angle is homogeneous and of degree 0. Now for this example, angle is homogeneous, no doubt, because here is 2 and degree of denominator is 1, total degree of this angle is 1. But we'll check this total function is homogeneous or not. What will happen if angle is not of degree 0? Means moreover angle is homogeneous but not of degree 0. Then what will happen? In previous two cases angle is homogeneous and our degree was 0. Now here I will replace u by tx, x by tx, y by ty, which is equal to sine of t square x square plus t square y square divided by tx minus ty. This is equal to sine of t square into x square plus y square divided by t into x minus y, which is equal to sine of t into x square plus y square divided by x minus y. I will write here this angle in this bracket. But this is not, we will not take this t outside. This is not equal to t into sine of x square plus y square divided by x minus y. That means this is not equal to something t raised to power, or here 1 u of xy, means u of tx ty will not write in this way. Therefore u is equal to sine of x square plus y square divided by x minus y is not homogeneous function of degree. Now this is not homogeneous, and this is not a homogeneous function. But interesting thing is that angle is homogeneous. Angle is homogeneous. Total function is not a homogeneous. Okay, I will again try to modify this. Shall I take this term sine to this side? Then our function becomes sine inverse of u is equal to x square plus y square divided by x minus y. Okay, are you getting why I am taking this? Because we are knowing that this angle is homogeneous, but this total function is not homogeneous. That's why I will take this sine to this side. Now this angle is homogeneous of degree 2. Numerator is homogeneous of degree 2, denominator is homogeneous of degree 1. Therefore total is 2 minus 1 is equal to 1. Means this total function is homogeneous of degree 1. Means I will say that this sine inverse of u is homogeneous function in x and y of degree n is equal to 1. Of degree n is equal to 1. Means what is happening here? Sometimes in some cases our function is not homogeneous. Means directly this u is not homogeneous. But if you are trying to convert this as this u as function of, means sine inverse of u, then this becomes homogeneous. Means I will try to write here, if given function u is function of xy, then either this is directly homogeneous in x and y of degree n, or this is not homogeneous. And third case, sometimes this function is not homogeneous, but we can convert into homogeneous function. That means u is not homogeneous, but f of u may be homogeneous function. Means in last example, this sine inverse, in this example this u is not homogeneous, but sine inverse of u is homogeneous. Okay, this is about homogeneous function, and we'll discuss next important article in coming lecture. Okay, thank you.